Hello guys. Okay, in this video my plan is to talk about problem solving techniques. So far we've been talking about different strategies, different characteristics of critical thinking. Now we are to the point that we can apply all those skills whenever they're appropriate and see how you can solve problems. Now, before I jump into the topic, I just want to check in with you guys. I hope you guys are staying safe during this chaotic period in the nation. Not getting into any trouble, staying home and protect yourself, and also your family members, because whatever we see on news and all over the media, it's not very pleasant on top of what we are dealing, like COVID-19. So just stay safe, guys. Okay, so this model is a model that help us to look at problem solving, and where we see that where problem has began, and also in a context where the problem solver needs to recognize a situation and where your action is required, and based on action on a series of steps in which you will make sense out of the situation and decide what action to take based on the guiding principles, and then implement those into action. So customer returns high-tech instrument, that's a situation. And just based on this model, I'm trying to give you guys a nice walk through this model. So there's a problem, right? There's a situation, and now you have to recognize, like, product has quality problem. You're trying to understand why this product has come to your store, why the person is trying to return. Now you have to make decision. What do I do? Whether you return, whether you make refund, or you cancel customer purchase order, repair product and return, make a new item. So this is like your brainstorming some of the solutions that you can implement. And again, this is not very complicated in a way if you are familiar with this kind of situation, but in life, same thing could happen. I have, let's say, I have to choose a program for PhD. Now, what do I do? Recognizing those situations, then thinking about different schools, then you choose which school is the best. And after that, you execute method models. Now here, you have to implement that decision that you have made to solve the problem. That's the implementing part. And somebody is like governance approach model. It tells you enterprise intent is be top product and service quality. So this is their motto. Let's say this is your sorry about that. This is your motto for the problem. Now, if let's say you don't have enterprise, it's yourself. So what is your intention? Get the best degree, or get the best career, get into the best school. Based on that core idea, you will solve problem, and this idea will influence your solution. So in your case, you recognize the situation, you make sense what should be done, and then you thought about different options and you have to choose one of them. Again, when you choose one of those solution, you have this underlying thoughts. We also call, your belief system. What do you believe about education? What do you believe about career? What kind of job you think is the best suiting for your personality? And based on those beliefs, you continue applying some of those techniques, solve the problem, find the best option. If you like the chart I gave you, from previous lecture, use that to solve the problem and see what are the best option in the process of decision making, and weigh all considerations and have many options as possible, many alternatives as possible. Then you see the outcome is pretty impressive, right? So that's the steps. That's a model way to look into the problem. But before we get into those problem solving, there are a few other basic steps you want to think about. So preparation or familiarizing states. That's similar to here, situation and sense making part. because here you're trying to first know what is happening on. So this stage includes the time spent in understanding the nature of the problem, the desired goal, and also the whatever is given. That's the first part of the problem. Production is in this stage. You try to look at you're the problem solver producing solution paths that defines the problem space. The production stage is, okay, you're generating more alternatives. Now these two, decision making and problem solving, they are not two separate entities. They go hand to hand. So here you're now brainstorming. You're trying to do, sometimes you do trial and error, sometimes you do mean end strategy. You do try a different approach that works best for you. So your point is you're producing many solutions as possible. And the third part is, during this stage, the problem solver yourself evaluates solution paths to select the best one. So this is where, if you think of decision making chart, you're trying to see which one has the best yielding outcome, which one has the best points for all the consideration, which option has the best 2/3 ideal rule applied. So you look into those process and you make that evaluation. However, the other part here is incubation. Now, incubation is the idea, a period in problem solving when problem solver is not actively working on the problem. And sometimes you need time out, right? You try so hard, and this has happened to me, trust me guys. Now, when I started doing this video recording, you might, I don't know if you can imagine, I'm not used to making videos for like 30 minutes, 40 minutes, even 20 minutes, because it's hard. There's nobody to talk to. I'm just like talking to the screen, and sometimes I feel a little weird like talking so long. Anyway, so at the beginning part, I have to do so many trials of the video recording. I try to say something, it doesn't come out right. I cannot control the monitor. You see that I still struggle with some of the parts. But the point is, you have many attempts, you try to solve the problem. Sometimes it does not work for some reason. It does not work. You don't get that best shot. You don't have that like a satisfying outcome. So incubation is the period you're taking yourself to relax. Just get out of this struggle, get out of this attempt to solve the problem. And I'll tell you my experience while this video recording. I tried, and there was one time I maybe trialed about 8 times, and it was already like over an hour I spent, and I was little frustrated. I can't do this. This is not gonna work. And I stepped away. I did not try anymore. It was already plenty time spent, and I think I also became too ambitious to get it done. And I stepped away, went to see my wife, see my child, and played with them for a little bit. Just totally did not think about the problem, did not think about my task. Then after probably about 30-40 minutes later, I came back and I did. Voila, I just got it in one shot. So I was able to do the video without multiple trials. So it's one shot done. So the idea is, when you try to solve a problem, don't push too hard, because your brain needs a break. It requires some time to process all those information, all those pieces, to put it together and solve the problem. I have a link here of Archimedes. He's a popular mathematic guy, and he shows this incubation, how it can be effective when you try to take a break and try to take a time out for yourself. So it's a moment where this sudden knowledge of a solution to the problem will come. The aha moment will arise when you spend some time in incubation. Now, the idea is like incube, which means separate yourself from the problem, keep yourself a little free from those tasks. And the next part is, actually I do this in class. Unfortunately, we're not doing it live. So I want you guys to try, because anytime you think about a problem, there is a high correlation between people's success rate in solving problem and also personality type. There's a quality in our personality we call perseverance, and another popular term is grittiness. The idea is, how gritty are you when you take a task? Now, there's a whole bunch of video. I think I have a video link here. I want you guys to watch that. And the video tells you, well, when you think about grittiness, persistence, or perseverance, It is not about your IQ. It is not about how smart you are. It is not about how strong you are. It is also not about how fast you can do problem solving. It is about your persistence. Like, the story of the bunny and turtle, the rabbit and turtle. Rabbit was fast. He can run like a super fast than turtle. But the problem with him was too distracted by crowd, too distracted on his path, and too confident about his speed and strength. So what happened, he ran and ran and ran. Before he get to the finish line, he just got distracted, and I know the different culture tells different explanation for a rabbit's failure or the defeat. In our culture, we say that rabbit thought that, oh, I'm already so far away from the turtle, I'm just gonna take a nap. And he was taking a nap. But turtle, knowing that he is slow, did not get distracted. He continued taking his small pace until he hit the end line. So that showed that, if you're persistence, if you don't have speed of rabbit, don't have speed of the strength of rabbit, but still you are able to succeed. The moral of this story is like, can you stay on your task? Now, this is very applicable when you talk about classes. Look at us doing online classes. You did not sign up for online classes. You actually signed up for in-class activities, right? Now, whole things changed. But do you give up now because things changed? Do you just quit? Or you will continue on your journey despite all those hurdles? So this test your ability to persist in the task that you have chosen. And I want you guys to, take this. I'm going to show you the slides. I'm going to post this on PowerPoint. So take this. So these are the acronym you use. There will be a couple of items, and you use based on each statement how true those statements are to yourself, and you choose very much like me, mostly like me, sometime like me, somewhat like me, not much, not at all. So choose those for these statements. Here are the statements. And so since I'm going to post, I'm not going to wait too long. So you read each statement and rate yourself using VMMS, MN, and N. And there are a few more. There are at least 12 statements. So once you rate yourself, what you do is the formula. For question 1 to 10, 1, 4, 6, 9, and 10, if you gave VMMS, MN, and N, choose these numbers. And for other questions 2, 3, 5, 7, and 8, and 11, use these numbers to rate those your scoring. And after you scored yourself, then add them up. So whatever total you get for those 12 items, add them up. And once you add them up, then you have to divide the whole number by 5. Right? When you divide by 5, you will get a range of score. So when you add 12 items, so the maximum score on this scale you can get, you divide by 12, not 5. You divide by 12 and you get in a range of, I cannot get my pen today. Let me see. Okay, there you go. So if you got, I don't know, 48, that's pretty high, right? That would equal to what? 4. So if you get 48, divide by 12, you get 4. And this scale, so if you get close to the 5 or 4, that means you are extremely greedy. So you don't give up. You give it all. Redo it if necessary, ignore giving up, take time to do it again, do it right. So I just like that. I don't think that's the exact meaning or the term grit, but it tells you what grit looks like. So if you see your score close to 5, that means you're very gritty. Give it up. If you are lower end, that means you are smart, you are intelligent, you have that capability, but you just lack some kind of persistency. So if you recognize that, it's easy to work toward, okay, how do I do this? Choose a task and don't give up. And I have done this item myself, and I find myself a little greedy. So I scored between 4.2 to 4.6. I tried multiple times, and if I look at my personality, the way I do things, it makes sense because I'm not the smartest one, but I am very persistent. If I take a task, I don't like to give up in the middle of nowhere. I like to see the end result, even like a simple task like I'm doing gardening. I don't like to give up middle of nothing. I just try to continue and complete the task and see the end result. That's where my joy comes. So greediness pays off in many aspects of our life. Okay, now we'll look at how we solve problems. Now here, when you tell yourself, problem solving has to do with how you define the problem. Now, and there are problems that sometimes you have like a single correct answer, right? So that means if you define problem very well, that will lead to a very definite answer. That means it's a clear problem, right? It can tell if we're getting closer to the solution. And if problem is ill-defined, if they're not well defined, then that will lead to far away from the solution. Why? Because there are so many possible solutions, and that means your problem, your goal is not very clear. Your problem is not well defined. So these are two ways to look at well-defined problems. You give you clear direction. Like for example here, what is the area of this parallelogram? Sorry. So if you know how to do the math, you would look at this. Oh, it's simple. You'd multiply 3 times 5. That will give you 15, right? So 3 times 5 is 15. The area of this parallelogram is 15 square inch. So 15 square inch. Now that you got the solution. How do you know that? Because the problem is well defined. Well, there is a length, there is a width, and if you multiply length by width, it gives you the area of the diagram or whatever you're trying to measure. What is the area of this whole thing? Well, again, you did the same thing. You add them up. 3 plus 5 times 2. So 8 times 2 should be 16. So the answer is 16. I think it's called circumference. I don't know. The area. Yeah, not the area. The whole length around the diagram should be 16 inch. How do we know? Well, if this is a parallelogram, that means the length of this is equal to the length of this, and the length of this side is the length of this. So if you add them up, you get 16. So if you have a clear definition for each problem, your answer is pretty straightforward. It gets close to actual goal. But if I ask you write a beautiful poem, now that is not well defined. Well, what is beautiful? Somebody writes a poem about violence. Well, there are many possible answers. So if you write about violence, some people like it. It is a good poem or a beautiful poem for them. But some people like about love and romance. That's good for them. So all these answers are correct. What does that mean? Your ill-defined and well-defined problem will get you closer to the correct answer. Now, when you think of well-defined problem, that means you have very clear direction and goal for yourself. I should get serious about my life. And if you have to restate this in a multiple ways to generate other solutions, well, what are some goals to get serious in my life? Well, here, become responsible. Well, possible solutions: find a job, move out of parents' house, complete education. Those are possible goals. So when you have a clear definition of the problem, it will lead you to some options. What can be done based on the goals? Excuse me. And when you have those goals, now you work toward those goals. The problem planning and representation. That's what it looks like when you have a goal and possible outcomes. Now, there are a lot of strategies we use. Even like think of going back with our previous lecture. If you have this as your problem, getting serious in life, become responsible, you would make a chart, right? What are some options that makes me responsible? And based on those, you look into this option A, option B, option C, and you look into consideration. What are some areas that you should consider before you solve the problem, and you mark those consideration and you rate yourself. See, it's super easy. It becomes like a second nature looking into those aspects rather than just the basic strategies, the pros and cons. Pros and cons are helpful, but it will miss some of the components that you would see, dimensional comparison. You cannot compare these different dimension in pros and cons. Why? These pros and cons are only for one problem. And if you have to compare, then you have to make a separate pros and cons. It's a little tedious, versus this one gives you a clear perspective about each option in each consideration. Now, we use many strategies to solve problems, and normally I really enjoy this part of the lecture because I have so many activities that you can enjoy, you can do. So here, one problem, and even we are not in class, I want you guys to try problem solving and representation. So here you're doing is draw a graph or diagram. So to solve this problem, sometimes the hint is drawing a map. So that's the point. So if you want to find, Irvin has begun a jogging program. He jogs 2 miles north, then returns right and jogs 3 miles, then head left 1 mile, then return and jogs 1 mile to the right, then jogs 3 miles south, and finally 5 miles west. How far is he from his starting point? Now you figure. Now if you just try to solve this problem in your head, you'll be, unless you are super good with GPS, your direction knowledge, you're genius. I don't know where he is now. I think he is lost. That's what I feel. So if you know how to solve this problem, then you need to, if you want to know how to solve this problem, you need some strategy. One strategy we use in when multiple steps that involve multiple layers of problem, and you represent those in different lines, the point is write in a piece of paper. Write in a piece of paper. Now, if you start north, let's say this is north, and now you try to start, where did he begin? He started in north, and we use that point as the beginning point, and now you tell he jogs 2 miles north, so he went 2 miles up. Now, another way to be more clear is if you indicate mile and 2, 1 mile 2. Now, I'm not going to draw the whole problem, but I want you guys to try it. Let's see where he ends up, and I'm sure you will find the right answer. It's a well-defined problem. You will have one correct answer. I'm not going to tell you the answer yet. Okay, and the other part is using a table. So another diagram you can use. Again, this strategy, this problem is to teach you guys how to draw a problem in a chart. So here there are 4 dogs sitting in front of their dog houses. The dog in the left to right order are Pizza, Tiger, Lady, and Sancho. Based on the information given below, figure out which dog eats Crunch Blend dog food. Now, if you just read them all, I cannot figure out. So what I have to do is draw a chart. So I cannot draw other figure, but this will help me. Okay, here's the solution. I will have the name of dog, and type of food they eat, and their house name here. Now I'll write their problems here, then I'll figure out which dog eats the Crunch Blend dog food. Again, I'm not going to give you the answer, but I want you guys to try and find the answer. The point here in this problem solving strategy is you're trying to use different approach. Here in previous example, you used a map. Here in the second example, you're going to use a table. And this problem solving strategy, if you learned well, goes a long way. I'll tell you one example, because I was getting ready for GRE exam, graduate record examination, and they had a similar problem. You wouldn't believe that, though that exam is like a pre-requirement for applying for PhD programs, and they have similar problem. And when I know this technique, it was super easy. Why? Verbally it seems so jargonic. I don't know if that is a term. Too much jargon, right? But if you put it in a small piece of paper, develop a strategy, voila, that's the solution. So that's another approach you use, drawing a table. Now here, form a sensible word. Now this strategy has to do with trial and error. Sometimes you don't know exact solution. So if I give you these words, these hint words, what are some solution words that you can think of? Now I want you guys to try. Of course, you can see already some of the solution, but you might need to try a couple of times. So trial and error is making the solution attempt, and if it doesn't fix, then you try again. And oops, never mind, I have the answer there. But here, there's the task. So this one, use those following letters to make 5 words. Again, this problem also requires you to do some kind of trial and error. And here's another problem. Now, for your trial and error approach, you can draw, and so this is the shape that you can replicate. So here's the guideline. Draw this shape with one continuous line without lifting your pencil off the page and without crossing or retracing. So I cannot do this. I'll show you this. So I cannot do this and come back. That's not allowed. I cannot go this way and cross the line. Retrace is not allowed. Lifting hand and moving around is not allowed. So it's a tricky situation, and you might need multiple trials. So if you can think of it, try it. This is fun. I used to do this on my whiteboard when I teach in class, but now we have to do it separate. But I'm sure you guys will have some fun. And this one is mental set. Mental set, I think we already tried this. So when you are given a certain problem, sometimes you are a little fixed in certain solution, right? We tried this using 6 pencils and trying to create 4 equilateral triangles. Now, if you did not know you can do more than 2-dimensional thinking, you would be stuck with like trying these ways, right? You try to put things different ways, and some students try to do, I don't know, they try to do this way. So you try different approach, but none of them was correct answer because you are fixed in this 2-dimensional thinking. As soon as you thought beyond 2 dimension, here's the solution, right? You have 3 pencils on the flat and you raised 3 other pencils next to those points, and you get equilateral 4 triangles. So that has to do with, how to overcome this fixed mindset. Now, functional fixedness is again, you don't think outside of box. Now here's the problem. Complete the following letter series. This problem has used in IQ test for English children. Now this is the order, right? What are the next 3 letters? Think about repeating sequence of letter will lead to blind paths. So this is interesting problem. I want you guys to try. So OTTFFSS, you figure. This is a thing. Can you think out of the box? Now I already give you some bias. I gave you some repeating letters. You might be thinking next letter would be, I don't know, I cannot guess, maybe UU, ZZ, XX, but none of them are correct answers. And I want you guys to try. And once you find the answer, let me know. So hopefully you will find the answer, how to get out of that set mindset. Here's another situation. It's a problem solving strategy. Generalization is a problem solving strategy in which the problem is considered as an example of a larger class of problems. So generalization is you look at the problem, use the strategy to apply that strategy as if it is a problem of a big group or big class. So all parents try to make life difficult for their children. So that's one example, right? So you look at the difficulty for children is a general problem among parents. So exams are hard in university. So you're applying that knowledge that exams are difficult for anybody who takes classes. So you use strategy to look at this problem in a bigger perspective. Specialization it involves considering the problem as a specific case. Now it's not for everybody, not for every parent, not for every class, but it is one specific case drawn from a larger set of problems. My parents has these specific rules. I don't know about other parents. I don't know if they have rules, but my parents do. My professor is tough in his grading approach. I don't know about other professors, but my professor is a pain in the butt. So I don't know if I'm one that kind of professor, but you understand the explanation. Now here's some challenge for you guys. The alphabet is represented below in 2 rows. What is the rule that determines whether a letter belongs in the top or bottom row? So you have to figure out what kind of rule is applied here. If you look at this set of letter and if you look at this set of letters, so what is the rule that is applied? Now this is where you will be challenged about thinking, okay, what do I see in a pattern, what do I see in a commonality among those problems? Is it unique to one particular letter, or is it unique to all of those letters? So you've tried to solve this problem. Again, I'm not going to give the answer, but I'm sure you will try this out. And another strategy is means end analysis. Break problems into mini problems or sub problems and set sub goals. So this is a popular game, Tower of Hanoi, where you have to solve a problem, and there's a link. If you guys want to play it online, you can do it, you can try it. And again, I used to play this in class. So when problem is well defined, you can solve this whole move in 7 moves. Let's see if you can do it. So click the link and you will see the game. So if you want to play this, you can try first 3 discs. Then if you want to try more, then you can add more discs to make it a little more complicated. But if you have only 3, you can solve in 7 moves. Say let's see if you can try it. So how do you solve these kind of problems? If you have multiple layers, well, you cannot solve whole problem in one attempt. That's why you have these 2 towers. And how do you solve that? Well, you have to break down the problem into small pieces, and each small piece of problem has small piece of solution, small piece of goal. We call sub goals and sub problems. So means end analysis means what is the ultimate goal for this problem, and you break that ultimate goal into small pieces, analyzing those problems, and you solve small problems as well. Now, what's the application here? If you think of our class, now our class in general is a big problem, right? If you think of getting an A for the class, that's a big problem. How do I reach that A, the letter grade A? Well, you cannot just get A at the end of the quarter by doing nothing. I have broken down them into 3 exams. So I'll just write 3 exams and 9 modules, right? So many pieces, and each module have multiple assignments. Do you see that mean end solution, mean ends analysis? You break down problem into small pieces, you take that small bite-sized problem and solve the problem. Well, that's the way to come to your end conclusion. That's another approach, a strategy we think. And sometimes we need to think backward, right? And here's another example for that. In a lake, there is a patch of lily pads. Every day, the patch doubles in size. If it takes 48 days for the patch to cover the entire lake, how long would it take for the patch to cover half of the lake? Now, let's see if you guys can solve the problem. Now, there's a problem, and sometimes you need to go backward. That's the hint. If you guys were thinking it takes 24 days, wrong. Oops, never mind. That's the wrong answer. I was supposed to say wrong answer. Well, the problem here is instead of going 1, 2, 3, 4, what you did was it says every day the patch doubles. So how long it takes to get this 48, cover the whole lake. So 48 days. So half of the lake is full a day before that, which is on day 47. The half of the lake was covered. The next day it doubles. That means in 48th day it was doubled and filled. And in 46th day you see 1/4 was filled, and you go backward. So in sometimes backward problem solving might help, not all the time, but sometimes you have to see if you had the end result, can I go backward, trace back. And that's it. I think you guys have played those like maze, finding a pathway out. Like sometimes you do that. Sometimes instead of going from beginning point, come from the end point, so you can find your way out. So, and same with the life problems. So let's say again, I think of like you want to make you want to save $10,000 because you want to buy a new car. Now you cannot have 10,000 right away. Probably you might need to try a different approach, multiple approach. Ends mean analysis would be one helpful, but the other one is like, okay, how much I can save to get to that 10,000. How much do I take to save 5,000? How much time do I take to save $1,000? How much do I take to take $500? And when you go backward and you realize, oh, it's gonna take me this many number of days to save that money. So problem solving applies in many part of our life. And here's another similar problem. I think we already focused. So we saw this like similar trial and error sometime, trying different approach. Now, the last problem in this chapter for you guys is, so let's see if you can be mindful. Now, I'm gonna, if once I press my button, you will start seeing this letter drops down. So read as fast as you can. Or I'll read it for you. Suppose you are a bus driver. On the first stop, you picked up 6 men and 2 women. At the second stop, 2 men left and first woman boarded and on the bus. At the third stop, 1 man left and 2 women boarded. At the fourth stop, 3 men left and 2 women boarded. Okay? What is the bus driver's age? See if you can answer the question. So that's pretty much, I'm sure you did, because I think I was a little slow in presenting the problem. Okay, that's pretty much for you guys, and that is the end of the chapter. I think I'm not gonna talk about creativity because I'm gonna keep this chapter out of the syllabus, so I'm not gonna talk about it. So that's pretty much for this quarter. Actually, it was fun talking about critical thinking, and I definitely miss interacting with you guys, and I wish you good luck with your future endeavors, and stay safe. I'll see you guys around on campus. Have a wonderful day.